Welcome guys. Let's move on to video 4, which is titled JMeter Architecture. At this point, we have understood the importance of performance testing and its concepts. We have also had an overview of JMeter as a reliable tool for a cost-effective load testing project. Now let us have a look at the JMeter architecture. JMeter works in a master-slave architecture for generating concurrent user load on the application. This is also called as distributed testing. The components of this architecture are: number 1, master, the system running JMeter in a GUI or a non-GUI mode, which controls the test and maintains all test data files and its results. This is also called as the test controller. Number 2, slave, the system running JMeter server, which takes commands from the GUI and sends requests to the target system. Basically, these are agent machines which are managed and controlled by the master machine. Number 3, target, the web server of the application we plan to do load tests on. The prerequisites for doing load testing using master-slave architecture are: number 1, the Java version on master and all slave machines will have to be the same in order to successfully run a load test. All the agents should be in the same subnet as the test controller for avoiding network issues while running performance tests. The version of the JMeter tool installed across all machines have to be the same as well. For configuring the slave machines, the local IP addresses of all slaves have to be configured in the test controller machine by updating a parameter in the properties file. This will be covered in detail later in the course. The master machine will have all test scripts stored in it, and all test data files will have to be distributed equally across all slave machines for maintaining uniqueness of data during test executions. Now let us have a look at the architecture diagram of a master-slave configuration. As we have seen, this is the master machine, also called as the test controller. All JMeter scripts are stored here and are ran during test executions. The 3 slave machines below are also called as the agent machines. All test data files are distributed across these slaves. The IP addresses of these slaves are configured in the test controller, and then the test is triggered once all prerequisites are completed. During a load test, the slave machines use the scripts placed in the controller and then send requests simultaneously to the target system, which is the web server, and the response received from the server is organized and sent back to the controller for result collation and analysis. There are some basic limitations for distributed testing, which are: number 1, RMI cannot communicate across subnets without a proxy. Therefore, neither can JMeter run without a proxy. Number 2, since JMeter sends all the test results to the controlling console, it is easy to saturate the network I/O. Hence, it is a good idea to use the simple data writer listener to save the results and then view the file later with one of the graph listeners. This will also be covered later in the course. Number 3, unless the server is a large multiprocessor system, in most cases 1 or 2 clients are sufficient to overwhelm the server. Number 4, a single JMeter client running on a 2 or 3 GHz CPU can handle 300 to 400 threads simultaneously depending on the type of test. An exception here is the web services test executions. XML processing is a CPU intensive and will rapidly consume all the CPU cycles. As a general rule, the performance of XML-centric applications will perform slower than applications using binary protocols. In some cases, the firewall may also be blocking the RMI traffic, hence will have to be disabled. This concludes the section 1, which is called as Introduction. To summarize, we have covered 4 topics in this section: course agenda, Introduction to Performance Testing, JMeter Introduction, and JMeter Architecture. The next section is called as Installation and Overview. Thank you.